Welcome to the Balluff Tech Talk. So today we're going to be talking about condition monitoring. Quick introduction, my name's Neill. I'm the marketing manager for Balluff in the UK, and joining me today is my colleague Martin Sharman, who's the head of our technical support department. So together we're going to give you a run through of very generic run through of what it means and what we mean about condition-based monitoring, how we can implement it and the benefits that you get back, and then we'll give you a practical demonstration to illustrate some of the metric points that we can measure, some of the things we can measure, and how you can implement that onto your system. So first of all, we need to ask the question, why monitor your machine? So it's one of the easiest ways and most efficient ways to implement a predictive maintenance strategy. It provides you with the necessary data for process optimization, for analysis of your equipment, and allows you to make really good business case decisions about when to maintain, when items of plant need attention. And it also ensures the safe operation, availability, durability, and reliability of your machinery and your plant and your processes. So the purpose of continuous monitoring is to detect anomalies first and foremost, and predict possible failures as soon as possible, and avoid the consequences of unplanned stoppages in plant. So obviously reducing downtime has the massive benefit of increasing uptime and overall equipment efficiency, and really good machine diagnostics allow you to perform and implement proper inspection plans and predictive maintenance when it's required, which is the most important thing. So by constantly reviewing the performance and the status of the machinery and the condition of the kit, we're reducing costs related to breakdown and stoppages, and also the replacement of devices prematurely, because one of the first things to go usually is the maintenance budget. And we all know the cost of a large maintenance stock of spare parts. So condition-based monitoring or machine monitoring allows us to observe the parameters of the machines and the devices, and to control the quality of the production, and most importantly its efficiency, which is what we're all aiming for. So typically, what can we monitor in industry? What do we want to monitor? So we may want to look at various measurement points, typically vibration, temperature, humidity. Depending on the process and the manufacturing process, you might want to, specifically the humidity in the medical industry, etc. We might want to monitor the inclination. We might want to look at the number of working hours that the piece of kit's done. So how long has it been in service? The internal temperature of the devices, especially in control cabinets, and also signal quality. So, how are the various sensors and pieces of equipment performing? Next slide, yeah. Okay, so what can we monitor? Okay, obviously, for things like vibration, we can monitor the bearings, we can look at gear sets, pumps and linear drives, motors, conveyors, fans, and in the machine tool industry, spindles itself. We can also look at monitoring the internal humidity and temperature of control cabinets, and also monitor the stress on the power supplies. So we can look at the current consumption, their peak current consumption or on demand with switch on, and also things like their internal health. So again, the power consumption that they're taking themselves, but also their output power ratings. So, wide range of applications. Click through again and it will come up. So we could be looking at, not the most clear graphic, but we could be looking at conveyors, we could be looking at ventilation systems, pumping systems, robotics, and machine tools. Various metrics around those pieces of plant where we can monitor things like the vibration, the flow, the pressure, the temperature, the humidity, all relevant, and all this information we can take back and profile reports and actually give you trend data of how the system, the overall system and the individual machines are performing. So break it down into various different areas. So for argument's sake, if we're looking at a motor, what do we want to look at? So obviously the main goal, the ultimate goal is to avoid unplanned downtime. And we can do this by continually monitoring the bearing sets. So we're looking at vibration, either three-axis vibration acceleration. We can check for imbalance based on the vibration levels. We can monitor the temperature of the motor itself. We can monitor the speed of the motor. And also we can monitor the current consumption. So again, how much of that motor is, or how much demand is being placed on that motor at that specific time. And these are all important points we can take back. We can monitor and set limits. We can detect overloads, and we can identify trend data. So we can look at the lifespan of that motor through a shift, through a week, through a month, through a year. And obviously then we can use that data to say and see when that motor needs to be maintained or serviced. The ultimate goal is to extend the service life and ensure the availability of the plant and kit and minimise production downtime. So, and obviously, again, reduce maintenance spares. You know, we know over recent years that the demand and the availability of heavy gauge pieces of plant has been dramatically reduced, and the cost of those pieces of plant has increased. So if we can predict when we need to maintain a piece of plant or predict a fault before it becomes critical, we can plan that into our maintenance schedule. If we want to look at a pump, for argument's sake, again, we can monitor the pump in various different ways, and we can use the information that we receive from the various sensors that you can use to give us timely warnings and scheduling service data. So we can look at, again, the vibration, the temperature. We can look at the pressure and the flow that we're getting from the pump. We can check for cavitation by monitoring the vibration, etc. And again, we can access that data, and we'll see shortly through the practical demonstration that Martin's going to give the fact that we can utilise that data and we can send that to either a higher based maintenance management system or software package, or visualise it locally like we're doing on the training rigs at the NFPC here through utilisation of some of the equipment we'll show shortly. Fan monitoring. Okay, so in most production environments, the fans are not necessarily accessible. So they're quite often in places that require height work. They are invariably critical to the production process. So if the fan or the extraction system fails, effectively, depending on the process, that could mean loss or complete stop of production. So again, we can use various sensing technologies, and we can monitor things like vibration, speed, air pressure, air temperature, flow, and we can take that information and produce again trend data as to the performance of that piece of plant, and that helps us to visualise what's actually going on, and again scheduling maintenance. So yeah. Some typical examples that we will see or you would see on a plant. So in this example here, you can see we're monitoring various metric points on the fan. So we're actually looking at the fan chamber itself. So we're looking at the temperature, but also the vibration here, so we can detect if we've got any lost impellers. We're monitoring the bearing sets on the coupling, again for alignment, and we're also monitoring the bearing of the motor and contact temperature. So again, we can look at the various areas of the motor panel, of the motor fan assembly, and pick up some trend data and monitor the various metric points. We're feeding all that information back. That will be sent up to either a higher-based, cloud-based system, or will be visualised externally, as Martin will show shortly with the demonstration of our equipment. Critical again into a manufacturing process. In here we're talking about in the food industry. So with various mixer sets, so they could be mixing fluids. In the dairy industry, it could be milks, creams, butters. In the The baking industry, primarily we're looking at things like dough mixers, so lots of heavy vibration, lots of heavy work, and invariably, if any of these mixing pumps, mixing motors fail, we're again a complete stop, loss of production, massive downtime, strip down and change a motor on one of these sets. You could be looking anything up to a loss of one complete shift. So equate the costs involved for that downtime, anything that we can do to predict that and then schedule maintenance at the right time to prevent a catastrophic failure leads to increased OEE. And again, in the machine tool industry, we can monitor various metric points. So we're showing a couple of examples here. So we're actually monitoring the vibration of a spindle. It could be on the drives or on the individual motors itself. We also monitor the coolant systems, so the pumping systems for the coolants. So again, any integral part of that process of that machine that invariably would mean a catastrophic failure or a loss of production, we can monitor those metric points by using various sensor technologies, not unique to Balluff. We can incorporate within condition-based monitoring standard digital PMP, NPN, analog sensors, as well as intelligent sensors. Okay, so a little bit of information from us about the condition monitoring toolkit. So this is the Balluff system. The condition monitoring toolkit is an edge gateway which allows us to take the metrics from various sensors and present them in a usable format for the end user, for the customer. We can take any sensor from Balluff or from a competitor. IO-Link is an open standard. This is based on an IO-Link master, so it's an open protocol. So you can use any manufacturer's standard or digital, analog or IO-Link sensors with the CMTK. And what the Edge Gateway does is it allows us to take the information, measure the data, and present the information in a very usable, easy format. It's a plug-and-play system. It's very easy web-based configuration. We can either show the metrics locally on a HMI or a screen, or we can export that data via various protocols, MQTT or OPC UA, REST API, and we can send that information up to a higher-based system. Martin will give us some examples when we do it. The other added benefit is we were talking about condition-based monitoring and what we do with the data. So the most important thing that we can do with any condition-based monitoring system is make the information usable. So the easiest system, and the easiest way to do that is to set alerts. So we have the capability to set pre-failure warning and failure levels. And within the CMTK, it has a built-in SMPT database, so we can send out text or email alerts based on the severity of that failure or that alarm level. So you might want to send that for a low-level alarm just to the maintenance guys, the relevant shift teams. You might want to send it to the maintenance supervisors, or even kick it higher if it's a more severe failure or a more critical piece of plant. You can send those alerts up to the production supervisor or even production management team. The system is completely flexible. You decide who you send the information to. It's your data. Yeah. And that's the other important thing. There's no licensing. The information's contained on the CMTK. It creates the Grafana platform, which Martin will show you itself. So there's no external licensing or annual licensing costs. It's your data, you own it. What we want to do is make sure you can use it in a usable way. So how do we visualize the sensor data? It's a very simple system to set up. Depending on the number and type of sensors that you have connected to the system, the Grafana platform, the Grafana graphics are automatically generated based on the metrics that you decide to measure. So we talked before that we can do things like vibration. So we can monitor 3-axis vibration or acceleration. We can monitor the peak-to-beat values. We could monitor RMS values. So you have to select which style of metric you want to monitor. Once you've decided which type of metric you want to learn, we can then go on to set alerts and alarm points. Again, it's all done via a drop-down menu, and very, very easy to customize. And as we started off talking about the discussion, the whole aim about condition-based monitoring is anomaly detection. So, you know, we all know that in the perfect world, when we set up a piece of machinery, you know, we'll have certain vibration levels, we'll have certain operational levels. As the piece of kit beds in, you're going to see some changes. Yeah. So the beauty of condition-based monitoring in general is that it allows you to get trend information as to what's actually happening over a period of time. We've had a few discussions this morning with people, in particular about manufacturing pieces of plant here that are going to be exported to other countries and installed modularly. So when you test the machine here, when it's installed at the end destination, you know, depending on the mounting systems, how it's installed, you know, the measuring metrics that you get here when you test that machine might be completely different. So the alarm points or the levels that you set may be different in its final destination and once it's under load. So the beauty of measuring the metrics and be able to give you that trend is once that piece of equipment is bedded in over a period of time, you might want to adjust and tweak the metric points, the alarm levels. And that gives you the visibility to see what's the normal operation of the machine over a shift, over a week, over a month, and also what the demand levels are on that pieces of plant based on load. So, you know, on a normal load, on a normal production cycle, your metric levels will be at one point, but if you increase production and you increase demand on that piece of plant, you'll see spikes. The anomaly detection allows you to compensate for that, but also the trend data allows you to see it and compensate for it on your alarm levels. And the system's designed to be scalable. So as you'll see if you've been around to look at some of the training rigs that we have now at the NFPC, you can see that they're utilising the measurement metrics and they're looking at not only Balluff equipment, they're looking at the health of the pumps, the motors, the hydraulic drives, and we're all displaying that information on the metrics. So we're able to cater for 4 sensors, but we can expand that system. So you can have a slave or a master device with multiple CMTKs or multiple slaves connected to it. So we can actually cater and expand the system out to read more and more metric points or sensing points, depending on the device that you want to monitor. So just a little bit about our sensor. So just to give you some information, please, if you've got any questions or you want to come and see a live demo, Martin's going to show us some information in a moment, but we've got the sensors installed here at the NFPC, and we've also got a demonstration on our stand outside. The orientation or the condition-based monitoring sensor we have is called the BCM, and in that one package we can do multiple things. And again, all this information we can use, we can record and log, and send to a high level. So we can look at, as we said before, velocity, 3-axis vibration or acceleration. We can look at contact temperature, we can look at humidity, and we can also look at ambient pressure, dependent on the device that you select. This is not common to Balluff. You know, any IO-Link sensor or intelligent sensor that's available on the market from multiple manufacturers now, the benefit of IO-Link is that it also gives you enhanced diagnostics. So we can take that information and we can use it and package it together in a usable format and present it that allows you to make best case decisions. The beauty of the BCM is that it's, as we mentioned, it's an IO-Link sensor, so it's a global standard. So you can use this on anybody else's kit and vice versa. It's completely parameterizable. Depending on the version that you go for, it's either IP67 or IP69K. IP67 with the membrane, IP69K without. So it's able to withstand harsh environments. And we can set pre-confined alarm levels and main alarm points. All of the processing is done on board the sensor, so there's no additional external processing. And then obviously when we've decided what metric data we want to measure, we can then select how we monitor that information. So we can look at the mean, the min-max, the peak-to-peak or the RMS values for vibration, etc. But the sensor itself also has its own awareness, like any other iLink sensor, iLink device. It monitors itself, it's self-aware, so it's monitoring its own voltage and current consumption. It's monitoring its own internal temperature, as well as the external temperature or the contact temperature of the device that it's fitted to. It logs its own operational hours, so it knows how long it's been in service. And more importantly, we can see how many times it's been rebooted. Practical demonstration. I'll hand you over to my colleague Martin.
Okay, good afternoon. What you can see here on the demo board at the moment, 24-volt power supply, a CMTK, a BCM sensor with a magnet, mountable magnet, very strong mountable magnet. On the device itself, we've already discussed 4 iLink ports. On our test rig out on the trade stand today, we've got an extension with an Ethernet IP master and a smart light built onto the side of the device as well. M8 connectivity, connecting back to our sensor, which is M12 connectivity, with the Ethernet IP extensions, they're M12 connectivity. Standard connection back over Ethernet, straight back into my PC. Connecting onto the dashboard, typing in the IP address, 192.168.10.1 on our device. We can see our dashboard. On the dashboard, we've got local machine, and we've got one singular CMTK set. If we go into the settings page, we can see sensor information. You can see straight away the connectivity into the ports. These are live processing, so they're cycling. If I was to remove from port 2 and into port 1, very quickly we'll get the update refresh, and we'll pull that data straight back in to the device. We're now connected and we're now up and running straight away. So let me put it back because of the alarm structure. There we go, straight in, connected and working. If we go into the sensor itself, we can see straight away the data that's come back off that sensor. We can see the process data that is live from that sensor, so what we're getting are X, Y, and Z, and our contact temperature. We have a 5th variant that we can select, which we can select from any of these drop-down menus, and we're going for status bits and variation severity zone A as a default. UDP parameterization, we can set up directly from the device, or parameterization through the IODD, IODD being the IO-Link device description folder, which comes with every IO-Link sensor or every IO-Link device. We can go through, pull back any information, so we know straight away the Balluff is the manufacturer, the product code, the hardware version, the firmware version, all information that can be used for diagnostics points of the sensor or can be used for understanding further into the sensor itself. We've got 22.5 bytes of data structure on this one particular sensor, so we can pull back large data structures. As you can see active here, we've got our data processor, so that's the incoming data. And the final piece at the bottom is our BCM wizard, which is our Balluff condition monitoring configuration wizard. So to use this, we can then select whether we want to communicate with a motor, a pump, a fan, or a compressor. So this process will select a motor, and we can either go for temperature, custom peak, custom RMS, or we can stick to an ISO standard 10816.3. So if we go for that particular version, we can then select 15:3, or whatever the requirement is depending on your particular structure. However, if you get out of the range structure, you will find the machine will tell you you are no longer covered under the ISO standard. We need to select what the hardware mounting of the motor is to the floor to give us more realistic connection. And then if you look on the sensor itself, you'll find the X, the Y and the Z orientation. This is very important when mounting onto the sensor, onto the motor or onto the gearbox. This allows us to get an accurate understanding of the vibration and the data coming back off that particular sensor. So it's looking for the two axes that are vertical to the drive shaft. For this purpose, let's just select 2 and move through. So it sets up the vibration understanding under the ISO standard. If we need to change the alarm structures or the pre-alarm structures, these can be adjusted at a later date or can be adjusted live in this process. It gives you the information as to what you're covered on the variable bits of data inside the device, and it also gives you the information about what it is on the ISO standard. The final process would be naming this NFPC today, and then carrying on. As you can see here, we have an NFP ISO standard with the IO link data communication and an amber warning light. The amber warning light tells me that I've configured it, but I've not deployed it. If I deploy it, I'll now go green. And I'll have an alarm status on a particular axis, on a particular vibration in the Grafana platform. So if we go back into the Grafana platform, which is already open on the top, close that and reopen it. We'll now see our data points that are in as per our vibration across the top. So we've got our preset alarm points, we've got our temperature, our X, Y and Z, our temperature in a graph, and our other data packs as well. If we input more sensors, we get more data coming in. If we have more masters in the dashboard process, we will have master 1, master 2, master 3, master 4, so we can cycle through the different devices on our controller. If we go back to the CMTK, as you can see, we've got database. Internally inside the CMTK, there is an influx DB, so we can store data internally. Or if, for example, you were having a SQL server, you could input the data and the connection path, and you can transfer that data straight back over to the third-party database. Email, SMTP, with or without SSL verification. So we would get an alarm structure and then send an email. We could put multiple receivers, up to 10 receivers into there, to then transmit that alarm. MQTT, message query telemetry transport, with or without TLS, meaning that we can transfer that data back out to external cloud offerings. We don't offer a cloud platform, but you can communicate back to third-party cloud platforms.
We've had quite a bit of experience, haven't we? So I mean, one of the recent projects we've done is with some condition-based monitoring equipment, including ours and some other metrics as well from other sensor manufacturers. And we've basically taken that information and exported it to a maintenance management software package that's third-party operated. So they're actually using the data and they're taking that information into their maintenance management software and using that to assign assets that are required based on the information they're receiving on the plant. So that's a perfect example of taking the sensor metric data and exporting it to a third-party piece of software. It's working very successfully. Yep. in a very rugged, robust, busy production environment.
So we also have OPC UA server and client functionalities, if necessarily needed. Docker is currently active on this device. As you can see, we have a Docker container running, which is our Balluff smart light indicator. If we have an alarm structure on our Grafana platform, which we have here, we have an alarm data. We can actually create an alarm structure, which is here. And internally, we can activate the smart light, generate the smart light, send the data across. You can see this on our trade show. We vibrate the sensor for more than a preset period of time. You'll have an alarm smart light activated on the dashboard or on the physical output from the IO Link master.
So the beauty of that is that you can have obviously remote notification via the SMTP database that sends an alert or an alarm to the maintenance team or the production management team, but you can also have local indication on on the control station or the operator station. So again, it's how we're using the data and making and visualizing the data that is actually an issue.
It's also allowing for speed of integration as well. So there's no programming or commissioning setup of the smart light to say there is a status error. It is very simply going through another web browser page, accessing and activating a smart light on a drop-down menu selection. So we don't need to go into Node-RED, we don't need to go in and rewrite the program controls or connect a PLC to it. It can all communicate internally with inside itself. On the Docker package, we're running at the moment the smart light output, but parallel to that we can also run inside Portainer any Portainer offering that we want. We're running at the moment Node-RED on this particular solution for MQTT data transfers to third-party controllers, but we're also looking at utilising the IFTTT functionality if necessary for certain customer functions. IT network certificates. Broadcast creates and generates its own IT certificate for you to give to the IT department for communication protocol. Network switch, it's got two RJ45 ports on the front which can be split, allowing us to create an external network on LAN 1 and an internal Balluff network on LAN 2. So we could put the two Ethernet IP masters to extend the CMTK's I/O capability, but then keep us completely separate so that we're not transferring those internal variables over the NFPC network. We're only dealing with what we need to do internally and not bogging down their network of data structure. And that's about it from the CMTK's platform.
Mm-hmm.
Software updates, if any software updates do come out, we would support and we would advise of any software updates.
Yeah. I mean, so that's just a flavour of the Balluff equipment. I'm going to open it out to the room. So, I mean, you know, do you guys, what's your involvement with condition-based monitoring? Do you have an offering of your own? Do you supply, or do you have condition-based monitoring solutions already in place? Adrian, we know.
I'm heavily involved in it.
Yeah, and I think you can see that, obviously, that going back to the first few slides that we talked about, you know, the benefits of condition-based monitoring are paramount. You know, we go back to anomaly detection. What's differentiating between what's the norm and what's a problem? And that will allow you in the long term to know more about your in-depth knowledge or in-depth information of your process, your plant, your equipment, your machinery, and assign maintenance assets when they're actually required, you know, rather than cyclic or, you know, on a specific schedule. So reducing downtime, the overall aim is increasing overall efficiency. So if you would like to see any more information or another demonstration, there are various sensing metric points being measured on the NFPC training rigs that we've worked with Adrian on. Not only Balluff, you know, lots of other manufacturers' equipment are on the rigs, and we're taking information, and information is being used on the health of the rigs. Come and have a chat with us and see the demo on the Balluff stand, and we're happy to furnish you with any additional information that you would need. And if nobody has any other questions,
Food's up.
I think food's up. But thank you very much for your attention. Adrian, sorry.
Can I just mention something? You mentioned it there about the maintenance, and we've all, if any of us have been involved with maintenance in our past careers, it's always this idea of the planned maintenance has always been the way to go forward. And when you start looking at organisations, especially when you start looking at people that hold the purse strings, they're very reluctant to have planned maintenance procedures in place, because it means they've got assets on shelves ready and waiting to be changed at certain points in time. This sort of approach makes it more attractive to go down the road of the predictive maintenance. So you only get the parts, you only need the parts when and if it's needed, because this tells you when it's needed. And if you look at not just Balluff, but all the other organisations that are in the marquee, a lot of you are actually physically getting involved in this, because it makes your systems more attractive to the end user. They don't have to have lots of assets laid on shelves or anything like that for a long period of time. They just get it when they need it. And having this ability to use this sort of information from your systems, I think is becoming more important as we go along, as our systems become more complex and everything becomes more expensive. It's a no-brainer. We're going to carry on with this in the NFPC. We're going to investigate this. We're going to move it on. We're going to see what we can do, what we can't do. And every time we add something else, it generates more questions about what can we do and what should we be doing, and what can people cope with. As you all know, we're starting to get heavily involved in the wind turbine industry, and that is a perfect example of remote condition monitoring. You know, you're looking at lots and lots of data, and we're already being told that half the time they don't actually understand what they're looking at. So you've got to know your systems before you can utilise these systems effectively.
That's always a big problem with anything like this, isn't it? It's the data, the amount of information you get, and then we're not particularly got involved with condition monitoring, but on a similar idea is just monitoring for a fault. So if something goes wrong and the machine breaks, you can backtrack to find out what.
So
but the amount of data you get, it just becomes
absolutely.
unmanageable.
I mean, the simplest form, if you're looking at the pressure drop across a valve, you need 2 gauges.
Yeah.
So then, instead of having 2 analog gauges, you now get a digital gauge which has got differential pressure transducers on it. So straight away, you're bringing up the complexity, but you're now making it more flexible, more useful for what you're looking at. But then now you're looking at a system, you're looking at so many different bits of information. Well, what does it mean? If you don't know what you're looking at, in the sense of you don't know the process, it's gobbledygook. I mean, I've had instances with people on courses actually saying that their company have installed lots and lots of data management systems, networking systems, sensors, but actually realise that they don't actually know what the baseline is, because it's old kit that's been in, you know, it's legacy equipment, it's been there for a long, long time. Well, the damage has been done.
Yeah, exactly.
So it's always making it, and the nice thing about, and I am a little bit biased towards this because I've played around with it for so long, is that you can take it out of the box, you can plug it in, and you can actually see, you can play around with those alarm bands and work out what suits you.
Yeah.
And I think that is really beneficial, especially IO Link. The ability to actually monitor your device and know when it's actually giving you the right information, it's still healthy. I think that's a boom. Wish I'd known about it 10 years ago.
It goes back to knowing the norm.
Exactly.
Yeah.
What's the norm for your piece of equipment? So,
Do you find that, I can't talk now, do you find that these big companies have a problem managing the data? Because there must be millions and millions and millions of data needs storing and...
We tend to find that from the solutions point of view, that they're only realistically interested in the error and the forewarning state. They're not interested necessarily in the process running state. So only when it gets close to an alarm state, a pre-alarm or an alarm or an error state, do they really need to monitor that process.
Yeah.
So this device will continually monitor the system throughout that whole process, but only really transfer any variable under the MQTT process when it's in an alarm state.
So has it got like its own recycle bin where
Correct.
it's... Yeah.
It's like a giant FIFO buffer that just sits monitoring its data for 128 days.
Yeah.
Depending on how much data you've got coming in, obviously that gets reduced, but it's
Yeah.
normally about 90 days.
Can you
in
define what FIFO means?
FIFO is a first in, first out buffer.
Yeah.
So it just stores the data and it just flops the unnecessary
Yeah.
data out at the end.
Yeah, that makes sense.
the thing that we're finding as well, that with some of the companies that we're talking to, is that they may already have condition-based monitoring on some of their equipment, or they have condition-based monitoring that is externally sourced. So they have people come in and do analysis over periods of time.
Yeah.
That's a paid service. And you only get the snapshot of the data then.
Yeah.
So the whole benefit of monitoring machinery, condition-based monitoring, because there are so many manufacturers' intelligent sensors that give you that feedback on the market at the moment, the ability to be able to put that together in a package, and that's your data. You own that data.
Yeah.
A perfect example is we've been in discussions with some brick and tile manufacturers, and the data is owned by the line builder. So the maintenance team in the UK have to request the information from the line builder in Germany, and it's chargeable. But they've already paid for the production line to be installed. It's their data. So, you know, the ability for the maintenance teams to be able to own the data themselves and analyse the data themselves and build up the trend of their plant health themselves and knowing when to apply the assets strategically and at the most cost-effective time is paramount. So again,
have your systems got any things for data protection then?
So the external process of transferring the data can be done over the OPC UA MQTT, but they also allow us to cover on
certification.
On TLS, which is basically encoded data transfers.
Right.
So there are levels of cybersecurity involved in this particular process. At the moment, this is HTTP, so you can log into it. You obviously need the passwords and stuff. But the future of the CMTK will be HTTPS, so secure connection to the device.
Right.
Just a quick question for Adrian. I don't know, it might be one you can answer. Have you tried it with a particle counter?
Working on it.
Yeah.
Working on it. The issue I've got is now I've got to talk to the particle counter suppliers to actually understand. I know what registers I need to look at, but now it's converting from Modbus to IO-Link.
That'll be a game changer. That if you can sort that one out, because I know at the moment the big push is to fit particle counters in line
Yes.
on solid kit.
Yes,
And then how do you manage the information you're getting out of it?
That's the thing is, and this is the issue that I'm having personally, the setting up of the systems, things like flow meters, particle counters, you know, they're using 4 to 20 milliamps, yeah, okay, fair enough, that's fine. You know, you can convert that fairly easily into a value of data, you know, the actual bits. When you start looking at your flow meters, one, they're not linear. So now, again, it's 4 to 20 milliamps, but it's not exactly a linear rate of rise of flow. But then when you look at the particle counters, I've actually got to find a register, a certain amount of data that's transmitting out. First things first, you've got to physically connect to it, so you've got to get the pins right, you've got to get the wires right. Oh boy, what's that for? And then you've got to physically find the right register, and then you've got to see whether you can access that register from the IO-Link system. Which is interesting now. I'm at that phase, so watch this space.
If you can crack that one,
I hope I'm going to. Yeah, it's certainly something. The thing is when we come to the visualization, no problem. I mean, I've played around with that, and Martin's given me some more ideas for things that I'm going to look at when I get a moment. But to visualize it, there's all sorts of options. The problem is like Graham said, the security bit. Now, like Martin said, what you do is you use that TLS, and it actually tells you, if you click onto the other one, you say, are you really sure about this?
States it as an unsafe data transfer.
It will tell you, you don't really want to do this. So there's lots of checks and balances, but again, back to the Grafana, it's an open source. I mean, we've had conversations about, there's forums where you can go and say, I want to do this, and someone will actually go and work it out, spend hours sorting it out, and then give you a dashboard that you can use. Which sounds great, but if you're a very large organisation, do you want them to be able to do that? Yeah, IT is not going to be happy, definitely. So again, that's one of the reasons why I'm pleased like Balluff are doing it. I know other organisations are doing it. They're coming out with their own versions that can be put into these things that we can utilise, which is good. Makes it more trustworthy for people.
That's tough.
Yeah. Data acquisitions.
Yeah, so at the moment, I mean, I'm pushing to get these things fitted into systems, and then the control guys say, well, what do you want me to do with it? Well, you've got 40 to 20 million. Yeah, I can display it, but that's
what does it mean?
This is the biggest
display a
problem.
number. As long as somebody's looking at the
numbers.
number, they're all right. If somebody looks at the number and doesn't know what it is, won't know what it is.
I mean, that was the biggest issue when I was looking at doing calibrating the flow meters, because when you start looking, then you're looking at someone else's equipment, and you've got to look at, well, what's their limits. So, you know, for instance, we've got a flow meter from a certain company, it goes down to that value, that's the minimum value. Well, I want to read down to 0 litres a minute, they can't.
No.
With that flow meter, I can only work between 1.5
Yeah.
litres a minute and 60 litres a minute. So what that means is I've always got about 1.5 litres a minute on my screen, but I know it's 0. So how do I offset that?
Yeah.
So then you start thinking about, well, am I doing this right? Am I getting the right value? So now you've got to compare, and it's interesting. But when you get it right, you've got data, you've got lots of data that you can
Your
utilise.
turbines are not the best, are they really? You want to go to a
Yeah.
volumetric one and then
Yes. We're looking at different options.
expensive.
Yes. That's the nice thing about the advisory, though, they help us out.
Speedy gets stuff for free.
No. Couple of discounted, yes.
Yeah.
Okay. Thank you ever so much, gentlemen.